The next part of the interface is templates. Templates should be considered a sort of blueprints on how to create VMs. A template contains all the description and objects that need to be present for the VM to be instantiated. So, for example, we need to know how much memory should be allocated, how many CPUs and virtual CPUs should be defined for them, if you want to add one or more disks, and for each of these disks it's possible to specify additional parameters, like for example if you want to override the target device, or if you want to specify quality of service variables like throttling in terms of how much the disk should be used in terms of total read plus write in bytes per second, only for reads, only for writes, and in total IOPS. This allows us to create VMs that can be perfectly controlled. It's possible to add additional disks when the VM is live. We can easily attach additional virtual networks up to 64, and it's possible to specify the kind of virtual machine that should be emulated, or if you want to change the boot order. It's also possible to specify additional hardware emulation capabilities, like the emulation of a CPI, if we need to have a limited form of Hyper-V emulation, or if the system should reschedule dynamically the VM to make them live migrate on the most suitable node in a continuous way. We support a dynamic screen which is created directly by the hypervisor, which can be connected through VNC or through a special protocol called SPICE that allows a full multimedia and USB remoting. It's also possible to decide how this VM needs to be scheduled, on which host we want to have them to be made available, or what kind of policy should be decided as to when to place the VM or when to move this VM if something happens to the nodes or the global load scheduling. The system that we use is peculiar. It's called Pvnu Scheduling. Basically, every node does contain an engine that simulates what will be the performance of the VM if the VM is allocated to a specific node. This is a number that goes from 0 to 100, where 0 indicates that basically the VM would run at the maximum speed possible. The system then tries to allocate all the VMs so that each VM is running as fast as possible. This, of course, is dynamic. It changes every time a new VM is scheduled or when a VM starts to use more resources. For example, a mail server starts to use more memory or more CPU. It's also possible to assign custom PCI devices or to pass specific values down to the VM. Templates can be connected together into what we call flows. It's possible, for example, to say that we want a first VM to start and then a second VM to start as soon as the first one is booting, or it's possible to create dynamically cascades of VM activation or auto-scaling. So, for example, we can increase the number of VMs if something happens. Like, for example, if we want a web server to start responding to an increase in traffic, so we create more copies of it. It's possible to assign individual networks or to create a network on the fly. A special kind of services are virtual routers that are automatically deployed when you create connected networks across different VMs. Virtual routers are generated by the system, and there are small custom VMs that directly route from one network to the other in an automated way.